Have you ever wondered how artificial intelligence, AI, learns? In this episode, we decode this often misunderstood process, explaining what machine learning is and how it works step by step. By the end of this video, you'll have a clear understanding of machine learning and its different types. Let's dive in. First up, let's tackle the basics. What is machine learning? Machine learning, ML, is a type of artificial intelligence where computers learn from data without being explicitly programmed. This might sound like science fiction, but it's the driving force behind many of the tech advancements we see today. For example, voice assistants like Siri and Alexa use machine learning to understand and respond to your requests. At its core, machine learning involves using algorithms to parse vast amounts of data, discovering patterns and making predictions or decisions based on those patterns. Instead of relying on pre-programmed rules, which is the traditional approach in software development, machine learning allows systems to learn from past performance and make better decisions over time. There are three primary types of machine learning: supervised, unsupervised, and reinforcement learning. Let's explore each of these. In supervised learning, algorithms learn from labeled data, meaning each input has the correct output. Think of it like a student studying for an exam with a teacher's help. The student uses textbooks and class lectures as training material, and the teacher's guidance ensures they're on the right track. Once trained, the algorithm can accurately predict outcomes for new, unseen data. Supervised learning is widely used for tasks like spam detection, where emails are labeled as spam or not spam, or in predicting house prices based on size and location. Next, we have unsupervised learning. Unlike supervised learning, algorithms here work with unlabeled data, meaning they must discover patterns or groupings on their own. It's like giving a child a box of blocks and letting them sort them by color, shape, or size. The algorithm searches for the most meaningful way to organize the data, creating clusters of similar data points. This approach is often used for tasks like customer segmentation, where you want to group customers with similar buying habits together, or market basket analysis, as in what products are frequently bought together. Finally, reinforcement learning is a more complex type of machine learning, where an agent learns by interacting with an environment and receiving rewards or penalties. Imagine teaching a dog to sit. You say, "Sit," the dog looks at you, and then you give the dog a treat when they sit down. The reward is the treat, which reinforces the desired behavior. In reinforcement learning, the goal is for the agent to take actions that maximize cumulative rewards over time. This type of learning is used in training robots to walk or grasp objects, game-playing AI like AlphaGo, and in self-driving cars to teach the car how to navigate roads and traffic. Now that we understand the types of machine learning, let's look at how machines actually learn. The process usually involves several steps. First, data is collected. Then it's cleaned and structured for use. Next, a model is selected based on the type of learning and the nature of the problem. The model is then trained using the prepared data and evaluated on some unseen data to measure its accuracy and performance. Finally, the model is tuned and optimized based on the evaluation results. This iterative process continues until the model achieves the desired level of performance. Machine learning is a powerful tool being used to solve real-world problems in various fields. From recommending new movies on Netflix to detecting fraudulent transactions in banking, its applications are vast. Machine learning also powers facial recognition technology used in security and social media platforms. Predictive text and language translation in mobile apps are also made possible by machine learning algorithms. Despite its numerous benefits, machine learning comes with its own set of challenges. Bias in the data can lead to unfair or inaccurate predictions, and the complexity of some models, like deep neural networks, makes them difficult to interpret. Additionally, the use of large data sets in machine learning raises concerns about data privacy and security. Overfitting, which occurs when a model performs well on training data but poorly on new data, is another significant issue. As we wrap up this episode, remember that machine learning is transforming industries and our daily lives in ways we're only beginning to explore. Stay tuned for the next episode in our series, where we'll delve into the world of deep learning and neural networks. Don't forget to subscribe and turn on notifications so you never miss an episode. If you found this helpful, please give it a thumbs up and share it with others. Your support helps us create more quality content. Thanks for watching. Until next time.